Now we'll solve these two problems. And the first problem says that if y is equal to x to the power x to the power x to the power x, which is goes to infinity, so basically we have to evaluate that ddx of y. So first of all, to solve these problems, we need some basic idea about how to solve this type of problems which goes to infinity. Let's try to solve the first equation or first question, which is y is equal to x to the power x to the power x to the power x, which is goes to infinity. Let's consider that all the above powers is look like the similar problems that is given as y. So we can write that y is equal to x to the power y, and then we have to differentiate it. But before differentiate it, we will take ln, because if we take natural log or ln, that in that case we can solve this equation very easily. So let's take ln both sides. So ln y is equal to ln x power y, and we can write that as y ln x. Now we will differentiate the both side, which is ln y is equal to y ln x. So if we know, when we differentiate natural logarithmic problems, we get something like that y over y, and as we differentiate that function or that part with respect to x, we will get dy dx. This is not appropriate way to read that. We should read it as ddx of y, and then this part we will apply the uv formula, and when we use uv formula, we'll get y over x plus ln x dy dx. We will get together the part ddx of y, so we get 1 over y minus ln x. The common part is ddx of y, and here we remain y over x. Then we have just evaluate that part, so we can write ddx of y is equal to simplified way of this part, y square over x 1 minus ln x respectively. So that's the value of ddx of y of this particular function, which is goes to infinity and seems like very hard to solve, but it's not actually that much solved. Similarly, we can solve the second problem, which is y is equal to sine x to the power sine x to the power sine x, which is also goes to infinity. So it's not a big deal to solve the problem, because we know that this part is look like as y. So we can write that as sine x to the power y. Then we again take natural log or ln both sides, so ln y is equal to ln sine x to the power y. So that means y ln sine x. Then we differentiate both sides with respect to x. So on the left side, we will write 1 over y ddx of y is equal to, again we use uv formula in that part, so we can write that y over sine x. Okay, fine. So it is not as ln x, so we have to apply chain rule in that part. So we'll get, again differentiate that part, cos x plus ln sin x into ddx of y. So again we put the common parts in one side, and then other side is not common part. So 1 over y minus ln sin x, and the common part ddx of y, and this part give us the value of cot x. So y cot x, then we can write it easily as that form, ddx of y is equal to, so simplified of this formula or simplify of this side, y square cot x over 1 minus ln sine x. This is the value of d dx of y, and which is comes from this function.